Welcome back to the presentation. We are at the point where we're almost done with discussing how we can do filtration in the concept or in the context of our RIP version 2 protocol with regard to IPv4. Obviously, we're going to entertain some of these aspects with regard to IPv6 when the time comes, but what I want to do right now is look at the next option that we have, and that next option is going to be filtration via AD, administrative distance. Remember, administrative distance equates to the believability of a route. Now, when we go in, by default, RIP has an administrative distance of 120. Now, we talked about in the context of theory. Now, what I want to do is I want to illustrate the fact that we have the capability of doing filtration using AD. And it can be either a broad brush, just generic do a filtration, or we can actually be selective with regard to how we want to do this manipulation based on neighbor. So what we're going to find is that I'm going to have the capability of doing this where I can do a AD filtration based on just inbound to the routing process. I can do it per network, and I can also do it per, and I really hate using the word neighbor since we're talking about RIP, but basically that's what it extends to, per neighbor. So let's take a look at what forms this takes at the configuration, and let's come up with a scenario. So I'm going to grab my eraser real quick, take this stuff out, and what we're going to do is, again, we're going to focus on a particular prefix. I want to focus on 11.11.8.0/24. Again, that's going to be that prefix running on R1. Now again, just like we know, everything's going to be advertised out. One second. Everything will be advertised out. Ultimately, it's going to arrive on R22. Now, when we look at this, let's make certain that we have everything up and operational. Make sure we have no artifact configuration left. So in order to be able to test that, all I'm going to do is I am going to do a trace route, same as always. So we'll do a trace route to 11.11.8.11. And now we see we're load sharing and we have reachability to that prefix. Now my point is, I only want to affect this individual prefix, but before we go that far, let's look at how we use this in a broad brush stroke. So what I'm going to do is I'm going to come into my configuration. So config T, router RIP, and what I'm going to do is I'm going to use the distance command. Now we see the distance command allows me to specify an administrative distance. What I'm going to do is I'm going to pick 121. And all I'm going to do is I'm going to hit enter. Now what this is going to do is it's going to do show IP route RIP. It's going to change the values that I use for my administrative distances. So let's wait and see what happens. Actually, what I'll do is do clear IP route star, do show run section router. Make sure the command took, yes, distance is 121. So do show IP route RIP. Notice now my distance is appearing on my table as 121. Now that changed the administrative distance on my platform. Now I may or may not, depending on the circumstances, want to make certain that all the other devices that are operating in my RIP domain use this administrative distance, but that's not what I want to do right now. I'm going to use this for the purposes of doing filtration. And what I want to do right now is I want to say that I only want one network to be with an administrative distance of 21, and I want that to be that 11.11.8.0/24 network. Let's look and see what happens when we do that. So when I come in here and I look at my distance, we said 121, and now notice I have the capability of specifying a source address. Well, I'm not going to specify a source address specifically. I'm just going to say 0000. 0 or 255, 255, 255, 255. And now what I want to do is I have the capability of referencing an access list. So let's just say access list 1. Let's see what this looks like now. Do show run section router RIP. So notice the syntax took Now I need an access list. So let's create an access list. Access list 1, permit, and what am I going to do? I want to permit 11, 11, 8, 0, 0, 0, 0, 255. Now let's see what happens, if anything. Clear IP route star. Show IP access dash list. Oh, I already had one in here. I bet I messed up. Yep, I did. Need to remove this. This is a danger in the exam. Always verify that you don't have a pre-existing access list. Because if you have access list 1 already and you do exactly what I just did, you're simply going to append to whatever you configure to the end of that. So rather than just simply delete it, I'm going to edit it. So what I'm going to do is I'm going to come in here and I'm going to say config T. I'm going to say IP access dash list. I'm going to say 1. No, I'm going to say standard 1. I'm going to say no 10, no 20. Do show run or do show access list 1. And there we go. All right, so while I'm here, I'm just going to say 40 and do my explicit deny. So deny any. Show access list. Let's see what happens now, if anything. Show access list 1. Okay, I've got some matches. Everything seems to be good to go here. So now let's take a look and see what's happening here. So show IP route, RIP, and let's see what we got going on. Well, right now it's 21 for everything. So let's look at this. Clear IP route star. Show IP route. Everything is still 21 for everything. 21, 121, 121, 121. Show run section router. Ah, look here. Do not get sloppy with your configurations. Distance can be either a specific defined distance or it can be a distance that we may end up using on a case-by-case or a neighbor-by-neighbor basis. So what I want to do is I need to remove this first distance command. So config T, no, so router, RIP, no, paste it in, clear IP route star, show IP access list 1, no IP or no access dash list 100, 101, do show access dash list, and let's get rid of 2. No access dash list 2. Show access list. We only have the 1. Things are looking good here, so show IP route. And now notice the only prefix that have been modified to 121 is 11.11.8.0. Now I can be even more singular about this. I could say that I only want to modify 11.11.8.0/24 if I learn it from a specific neighbor. So let's pick a neighbor. Let's say I want to make it 21 on 223.3 and I want it to be 120, it's normal on R2. So let's look at how we would do that modification. Show, run, pipe, include, access dash list, and we've got that, so we don't need to make the configuration here, so it's got to be under our running configuration for our routing process. So show, run, pipe, section, router. And sure enough, we see this. We need to modify this bad bear right here. So first, let's take it off. Config T, router, RIP, no, and let's take off the whole command. We don't want a repeat of last time. Okay, now gone. So now what we want to do is we want to say distance 121, and I want to match on an IP source address, so a via address. Now let's say let's just match on R3. So I'm going to say TN1 2233 0000, match exactly. And then what I'll do is I'll specify access list 1. End. Clear IP route star. Show IP route RIP. Everything's 120. 120. Double check my access list. Make sure I got my syntax right. Show run. Section router. So it should have changed the distance to 121 on anything matching the access list that I'm learning specifically from 10.1.223.3. So let's take a look at this. Show IP route 11.11.80 and see what we see. Well, look here. We only have one route in here, distance 120, being learned from R2. So it's gotten flushed out of the table. Show IP route doesn't show me everything that I would want to see, because what's happening here is remember, we're picking the prefix 120, but notice we only have one interface, where every other interface was two interfaces to reach it. We were doing load sharing. So if I come into the system right now and I do this config, what I'm going to find here is that this configuration is actually setting up to where I have the two prefixes, but the one is not making it in the routing table as a direct result of the fact that the administrative distance is 121. So the system is picking the lower AD, and that's the one that it's using for this specific route, because that's the only route that we're not going to be doing load sharing for. So let's take a look at that. So trace route 11.11.0.11, we load share. We're going through R2, R3, and then we're going all the way down to Cat1, Cat2, all the way to R1. Now, if I do this for -8, I'm only going to go through R2 as a direct result of manipulating this concept of my routing protocol. Now, how can I illustrate this very quickly to make you aware of the fact that that's what we're going to do? Well, first of all, let's do this. Let's see if I can't change the distance, the administrative distance for RIP on this device to something that's administratively higher than 121. So we'll say router RIP, we'll say distance 150. So let's just pick a value and hit enter. Now the question is will this change everything to 150, or will it change everything to 150 except the prefix that we wanted to have 121? Do clear IP route star, end, show IP route. Let's see what's going on in our routing table. Well, right now we see everything is 150 except for the prefix that we decided that we were going to attach with 121. And notice that's through serial to 1, which points to R3. So with that arbitrarily of changing the prefix or the administrative distance, I was able to test my entire configuration. But I do want to make certain that I turn it back to what it's supposed to be. So router RIP, no distance 150, do show run, section RIP, and everything should be good to go now. Exit, exit, clear, IP route star, and then wait for everything to come back up. Show IP route 11.11.0.0, two prefixes, R2, R3. Let's take a look at 8. One prefix through R2, because again, we arbitrarily changed the administrative distance on the prefixes that we're learning from R3 using that distance command, and we saw how we can do it for the process as a whole, how we can do it for a specific prefix irregardless of where we're learning it, and we also saw how we can do it for a specific prefix coming from a specific neighbor, to excuse the term. Again, it's not a link state protocol, so there are no true neighbors. It's adjacent RIP speaker. But with that being said, we've illustrated everything that we need to know with regard to how we can handle this idea of route filtration using distribute lists. So let's move on into our conversations and see if we can't touch some other topics. I'll see you guys in the next presentation. Bye-bye.